Hello, this is John from caveofprogramming.com. In this tutorial we're going to take a look at lists in C++. A list is quite similar to a vector, but it has some important differences. From a usage point of view, the difference is that you can insert items into a list at the beginning or the middle of the list, whereas with a vector you're restricted to just inserting items at the end. And the reason for that is with a vector all the different elements are stacked next to each other continuously, one after the other, next to each other in the computer's memory. And that's how come it's so easy to access them via an index. You just have to use the index to find the right memory block. With a list, it works a bit differently. A list contains a bunch of nodes which stores each element, and those nodes are linked to each other via pointers. So one node in the list has a pointer to the previous element, the previous node, and it also has a pointer to the next node. So if you look at any two nodes in the list, they have pointers to each other. So we call this a doubly linked list. And to get to traverse the list, to move across it, you have to get each element and get the pointer to the next element, and then get the next pointer from that, and so on. So you can't just use an index. So let's take a look at this here. Doubly linked lists are one of the really fundamental data structures in computer programming, in case you haven't come across them. Very worthwhile knowing about. Let's create a list. I'll create a list of int, and I'll call it numbers. Now we can add to that in the same way that we add to a vector. We can use push back here. So let's push back 1, and I'll copy that, and we'll have 2 more in there. Let's push back 2 and 3. So the idea is that inserting or deleting an element at any point in the list is just as efficient as adding elements at the end, which is great. So let's iterate through this. We're going to have to use an iterator because we can't use an index. So I'm going to say for list int iterator, and it's exactly the same as with a vector. Let's call this it and set it equal to numbers.begin. We'll keep going until we reach the end of the list, so numbers.end, and we'll use the overloaded plus operator on the iterator here to increment it, and we'll use the overloaded star operator here to output the element. So if we run this, it works pretty much as you'd expect, except that I've got a syntax error in there. I need to have 2 colons in there. There we go. I'm not sure if I even typed the right punctuation. Let's try this. So there we go. We've got 1, 2, 3. So what we can also do with this is there's not only a push back, there's also a push front. So we can use push front here to add an element to the front. Let's add 0 to the front of the list, and that's just as efficient as adding items to the end of the list. And then we've got 0, 1, 2, 3. We can't use plus equals 2 with the iterator, for example. We can't use plus equals. We can only increment it. We can only step forwards and backwards with minus, minus, or plus, plus. Let's take a look at adding elements and erasing them from other positions in the list. So first we need an iterator to the list to do this. Let's actually just copy this. We can just use this again, and I'll set it equal to the start of the list once more. So if we output this now, again I could copy this line here, then we get the element at the start of the list. So we've got element 0 there. Let's just put some text in here to make that a little bit clearer. Element, and we'll run that. So that's an iterator that references the first element in the list. If we increment that, of course, then we're going to get to the next element, which is 1. Now supposing we want to insert another element before 1, we can do that using the insert method. So I can say here numbers dot insert, and we need to pass the iterator and the number to insert. So let's just insert 100 so that it sticks out and we can see it. So if we run this now, we're going to get 100, and we see that it has actually changed the iterator. This has actually made the iterator, well, it's kind of pointing at, in a sense, at the same position that it was before, but we've inserted this 100 before what would have been the current number in the list. We've inserted an element before that, and iterator now points at that. It's probably worth checking this on your system just to see that the iterator does behave in this way. We can also delete elements from the list as well, and there's a little bit of a complication here. Let's suppose we now want to remove the number 100. How do we do that? Well, our list now goes 0, 100, 1, 2, 3. So we need to get an iterator to the start, iterate it forward, and then we're going to reach the number 100, and then we can output that. Let's output it to check for a start. So we've got some error here. Let's just check. Yeah, we can't obviously redeclare that again. What am I thinking? Let's have let's call it erase it for erase iterator, and here we'll increment erase it. And I'm going to output erase it here as well. So let's just run this. Okay, so now erase it here is pointing at element 100, and let's go ahead and delete that. So what we need to do is we can say numbers.erase and just pass in the iterator that references that number. Now, if I run this program, there's a good chance that it will work, but it's not going to be reliable. So it still says element 100, so this is still displaying 100, but that's purely by chance. Sometimes that will work, sometimes it won't. And the reason is that when you erase the element that an iterator refers to, you invalidate the iterator, so you can't rely on it. So what I did here is wrong. We shouldn't do this, because it's purely sort of by chance that the iterator is still kind of pointing in the same place, and it's by chance that memory hasn't been reused or something. What we need to do is, because the erase method invalidates the iterator, it actually returns a valid iterator that then points to the element after the one you erased. So we can say here erase it equals erase, and now we can successfully do this. So we can output element 1, which is what was after 100 in the list. So originally it was 0, 100, 1, 2, 3, and we've erased element 100 here, and then we've got an iterator which now points to 1, which is the element after 100. So you can erase and insert elements into a list even while you're iterating through it. Let's make another loop here, and let's try this. So supposing I want to say let's just run this just to prove. Now we've got two loops that are outputting the same thing here, so they're both outputting 1, 0, 1, 2, 3, 0, 1, 2, 3 twice over there. I'm going to get rid of this because we'll use this purely for inserting and deleting. So now my second loop, my first loop isn't doing anything useful at the moment, and my second loop's outputting 0, 1, 2, 3, which is what's actually in the list. So let's say here if thing referenced by the iterator equals let's say 2. Supposing we want to insert something before 2, we can do numbers.insert, let's say 1, 2, 3, 4. And we need to supply it with the iterator as well. Okay, so let's try this, and that should insert 1, 2, 3, 4 before element 2. So we've got 0, 1, 1, 2, 3, 4, 2. We can erase elements from that list as well. Supposing we want to erase element 1, so we could say if thing pointed to by it equals 1. And remember, we can't work with indices here, we have to work with iterators. So if it references the element 1, that's the actual number that I put in here, then we want to call numbers.erase, and we want to erase that element. Now the problem is, this is going to invalidate the iterator. So we need to set the iterator back to something that's actually valid. But the iterator is now, in effect, it's incremented twice because here we're going to point the iterator to the element after the one we've erased. So we go through the list, we find 1, we erase 1, we point the iterator to 1, 2, 3, 4. Then when a loop goes around again, it's going to increment the iterator again. So it's now going to point to 2. So it's going to skip an element because this in effect has it has actually incremented the iterator. So what we should do here is we only need to increment the iterator if we don't erase something from it. If we erase it, in effect we're incrementing it anyway, because erase will point the iterator to the next element. So we need to have an else in here where we do the incrementing of the iterator like that, and we want to remove it from here. Now this would run, this works fine. So if I run this, remember we're erasing the element 1 here. So I run that, and you can see that we've erased 1 from the final list that's being output here. And the only thing with this is it looks a bit inelegant. So it's nicer to use a while loop. In fact, I'll leave that as an exercise to you. It's quite easy to do, to change this to use some kind of while loop. So I'll leave that up to you, as I say. And if you want to practice this, obviously typing this code out, checking it for yourself, verifying what I've said is a really, really, really good first step to getting all of this into your head. If you want a bit of a bigger exercise with this, one thing you can do is to write a program that presents a menu, and depending on what the user selects on the menu, allows you to add or remove items from a list and then redisplays the list. It could also have a menu option to let you view the list. So it's kind of a little database. And if you want even more practice, you could use the binary files to actually implement saving and loading that list from the disk. Although, remember, you don't want to save things like lists themselves, because the pointers will be invalid when you load them again from a binary file. You just want to work out some way of saving the actual data in the list, the actual things you've inserted into the list, whether it's just primitive values like this or whether it's objects. But I'll leave that up to you. At the very least, if you want to remember this, it's really worth typing it out and verifying everything that I've said here. So that's it for this tutorial. Until next time, happy coding.